The Big Bang Theory is our best explanation of how the universe began. It states that the universe started from an extremely hot and dense state about 13.8 billion years ago. Since then, the universe has been expanding and cooling. The Big Bang Theory is supported by a lot of evidence like the redshift of distant galaxies and the existence of the cosmic microwave background radiation. The redshift of distant galaxies tells us that the universe is expanding. The cosmic microwave background radiation is a faint afterglow of the Big Bang. The Big Bang Theory is a very successful theory, but it doesn't explain everything. For example, it doesn't explain what caused the Big Bang or what happened before the Big Bang. Even though the Big Bang Theory doesn't explain everything, it is still the best explanation we have for how the universe began. The cosmic microwave background, or CMB radiation, is one of the most important pieces of evidence for the Big Bang Theory. It was discovered in 1964 by Arno Penzias and Robert Wilson, who were using a large horn antenna to study radio waves from space. They found that no matter where they pointed their antenna, they picked up a faint signal that seemed to be coming from all directions. Penzias and Wilson were puzzled by their discovery at first, but they soon realized that they had found the afterglow of the Big Bang. The CMB radiation is a snapshot of the universe as it was just 380,000 years after the Big Bang. It is very cold, only 2.7 degrees above absolute zero. This is because the universe has been expanding and cooling for billions of years. As the universe expands, the CMB radiation gets stretched out and its wavelength increases, which causes the temperature of the CMB radiation to decrease. The Big Bang Theory predicts that the universe was once much hotter and denser than it is today. As the universe expanded and cooled, it went through a series of important phases. The Planck Epoch lasted from 10 to the minus 43 seconds to 10 to the minus 36 seconds. During this time, the four fundamental forces were unified into a single force. The Grand Unification Epoch saw the strong nuclear force separate from the other three forces. The inflationary epoch saw the universe undergo rapid expansion. The electroweak epoch unified the electromagnetic force and the weak nuclear force. The quark epoch filled the universe with quarks, gluons, and other elementary particles. The hadron epoch saw quarks forming protons and neutrons. Finally, the recombination epoch began, forming neutral hydrogen atoms and making the universe transparent to light. There are a lot of misconceptions about the Big Bang Theory. One common misconception is that the Big Bang was an explosion. This is not correct. The Big Bang was not an explosion in space, it was the expansion of space itself. Another common misconception is that the Big Bang Theory explains the origin of the universe. This is also not correct. The Big Bang Theory only explains what happened in the first few moments after the universe began. It does not explain what caused the universe to begin in the first place. The Big Bang Theory is a very successful theory, but it is important to remember that it is just a theory. It is our best explanation for how the universe began, but it is always possible that new evidence will come along that will force us to revise our understanding of the universe. The universe is incredibly large. It contains billions of galaxies, each containing billions of stars. The galaxies are not evenly distributed throughout the universe. Instead, they are clustered together in groups and clusters. The largest structures in the universe are called superclusters. Superclusters are groups of galaxy clusters that are gravitationally bound together. The Milky Way galaxy is part of a supercluster called the Laniakea supercluster. The universe is also expanding. This means that the distance between galaxies is increasing over time. The expansion of the universe was first discovered in the 1920s by Edwin Hubble. Hubble observed that the light from distant galaxies is redshifted. This means that the wavelength of the light has been stretched out, making it appear redder. Hubble found that the farther away a galaxy is, the more redshifted its light is. Hubble's discovery of the expansion of the universe was one of the most important discoveries in astronomy. It provided the first evidence for the Big Bang Theory. The expansion of the universe is one of the most important predictions of the Big Bang Theory. It is also one of the most well-supported predictions, with evidence coming from a variety of sources. One piece of evidence for the expansion of the universe comes from the redshift of distant galaxies. As light travels through the expanding universe, its wavelength is stretched out. This causes the light to appear redder than it would if the universe were not expanding. Another piece of evidence for the expansion of the universe comes from the cosmic microwave background, CMB, radiation. The CMB is a faint afterglow of the Big Bang. It was emitted when the universe was about 380,000 years old. The CMB radiation is very uniform, but it does have slight variations in temperature. These variations are thought to be the seeds of the large-scale structure of the universe. The fact that the CMB radiation is so uniform provides strong evidence for the Big Bang theory. The cosmic microwave background, CMB radiation, is a faint afterglow of the Big Bang. It is a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB radiation is very cold, only 2.7 degrees above absolute zero. This is because the universe has been expanding and cooling for billions of years. As the universe expands, the CMB radiation gets stretched out and its wavelength increases. This causes the temperature of the CMB radiation to decrease. The CMB radiation is very uniform, but it does have slight variations in temperature. These variations are thought to be the seeds of the large-scale structure of the universe. The fact that the CMB radiation is so uniform provides strong evidence for the Big Bang theory. The CMB radiation was first detected in 1964 by Arno Penzias and Robert Wilson, who were using a large horn antenna to study radio waves from space. They found that no matter where they pointed their antenna, they picked up a faint signal that seemed to be coming from all directions. Penzias and Wilson were puzzled by their discovery at first, but they soon realized that they had found the afterglow of the Big Bang. Their discovery was a major confirmation of the Big Bang theory and earned them the Nobel Prize in Physics in 1978. The future of the universe is uncertain, but there are a few possibilities. One possibility is that the universe will continue to expand forever. This is known as the Big Freeze scenario. Eventually, all of the stars will burn out and the universe will become a very dark and cold place. Another possibility is that the expansion of the universe will eventually slow down and reverse. This is known as the Big Crunch scenario. The universe will eventually collapse in on itself. The fate of the universe is determined by the amount of matter and energy in it. If there is not enough matter and energy, the universe will continue to expand forever. Observations suggest the universe is flat and will expand forever. New discoveries could always change our understanding of the universe's fate.